Okay, next we're going to be talking about the test for independence. So let's swing on over to our textbook and talk a little bit about that. First of all, note that if you have my annotations, I've got to place on here a link to an alternate explanation of the test of independence. It's just from a different textbook. Not better, not worse, just a different one. So if for any reason this doesn't make sense to you, you can head over to that one and have a read of that guide too to see if that helps. Otherwise, always if you have questions or need help, just schedule a meeting with me. There's a link right in Canvas where you can do that. Okay, let's keep going. And basically, okay, we're creating this fictitious example here where we want to figure out whether or not robots have the same preferences for data versus puppies as human beings do. Okay, and so we're going to load up some data and deal with some kind of different type of categorical data. In other words, we have two sets of categories, and what we really want to know is, are those two categories independent of one another? Or if I happen to be a robot, will I be more likely to pick, one thing, as opposed to something else? All right, what's my preference? And so let's go ahead, we'll dig into that. It's kind of a silly example, but that's okay. We're going to come right over here. We'll go back to our RStudio Cloud, and we'll talk right here, and this will be the test for independence. All right, and basically we want to know, we have two different sets of categories. All right, the data can be divided up into two sets of categories. Are those two different categories independent of one another, or are they related in somehow? Okay, and so let's come right up here because I'm lazy, and let's grab this guy. Okay, we'll grab that, copy. We'll come right down here, paste this in here because let's get some data. And that's not the right one, so let's come over here. We'll find out what the right data is. So it's this guy right here. It's data from this planet. Read the section there, and it will give you the background on it. But meh, it's fine. Okay, so the next thing I'm going to do is I don't know what the name of that name of the data frame that's going to pull in is, so I'm just going to run just this part. I'm on a Mac, so I'm going to hit Command Enter. If you're on a PC, you can hit Control Enter after highlighting the code you want to run. Bing, and there we are, and I have JPEG 9. So let's put this in here. CHAPEK 9. Apparently you can only go there if you're a robot. All right, there we are. So that's what the data looks like. So we have one set of categories, robot or human, and another set of categories, what do they pick? Flowers or datas or puppies? Okay, well, we have a full set of data that hasn't a single number in sight. So what do? Well, we need to figure out some numbers. So what we're going to do is we're going to use the xtabs function. Okay, and if I come right back over here, I have a nice little explanation of how to use the xtabs function. Xtabs are cross-tabulate. I want to cross-tabulate choice by species. And what that's going to give me back is a matrix. All right, so a vector is a one-dimensional, right, or a one-liner list of data. A matrix is a two-dimensional list of data. Now, you could say the big thing, the limiting factor on both matrices and vectors are the fact that everything in there has to be the same type. But in this case, that's just fine, because what we have is we have column headings and row headings for our matrix inside. All right, and that's what xtabs is going to give for us. So let's go ahead. We're going to do xtabs, and we're going to use a formula. So for the first time, we're going to use a formula, and it's going to be an open-ended formula. So it's going to be the left-hand side we're going to leave undefined. So it's just going to be tilde, choice, and species, and that gives us our cross-tabulation. And we need to tell it where the data comes from. And in this case, we use the data function, the data argument, to tell it which data frame to use. So let's go ahead and dig in and do that. And so, what do we want to call this? Let's call this these frequencies. Copy. And we're going to paste this in here. And so let's go X tabs. All right, and it gives me the stuff. And it even has a formula, and it starts to tell you it wants a right-hand side formula. See, because it's got the tilde and then a dot. The dot means just put stuff in there. So let's go ahead. We'll do you can put in formula here. Typically, you leave that off because it's the first argument and it's just style, but it doesn't matter. All right, so we're going to do tilde. Remember, that's up in the upper left-hand corner of your machine, of your keyboard. And I'm too lazy for this. Choice plus species. That, and I can't spell them. Paste. There we go. And now we're going to do one more thing. Tab. We're going to put in data. And we want to put that JPEG. C-H-A-P. There we go. JPEG 9. Okay. And we will put this whole thing in parentheses so that it prints it out. Bingo! So we loaded our data. We printed out the first few bits of it, and then it gives us, so there's the first few rows of the data, and then here's our cross tabulation. Easy peasy lemon squeezy. All right, so let's come back here and let's go ahead and look at, well, wait a minute. I want to know, do robots and humans have the same preferences over puppies, flowers, and data? Okay. Now, I'm sorry, this isn't typeset very well, but we'll just keep on going. So humans and robots, do they answer in different ways? So the null is that human and robots will answer the same way, and we want to show that they don't. And so our null hypothesis essentially is that the probability of 1 saying they like puppies is the same as probability of 2 saying they like puppies. All right, so this is really kind of hard to read, but if we think about this, the first one's the row, the second one's the column. Okay, these will be just the opposite of Excel. Just always think the opposite of Excel because it's always rows, columns. And so we have the first row is puppy, and will the robot say the same as puppy as humans say as puppy, and so on and so forth. That's what we're saying. If they are the same or not independent of one another, then boom, they will be the probability of a robot saying puppy is the same as the probability of a human saying puppy, and so on and so forth. Oh, and actually, since the hypothesis is claiming the true choice probabilities don't depend on species, the person making the choice, we can let PI refer to the probability. Okay? In other words, the overall probability should be the same as the two individual probabilities. And if we keep going, bum, 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 boom. There we go. This becomes essentially our new formula for this particular calculation. Notice it's very, very similar to what we saw in the original formula. Okay, the only thing that's going to be a little more tricky is our degrees of freedom, and that's just the rows minus 1 times the columns minus 1. So in this case, we have 2 columns, right? Puppy or human robot, so that's 1, and we have 3 columns, so that is 3 minus 1 is 2, so 2 times 1 is 2. So that's how many degrees of freedom we have in this particular scenario. All right, so how can we do this test? Well, you can do the association test. That's with using this command, association test. That's with LSR, but we're not going to use that package. So let's just keep going. And really, the easiest way to do this is we're just going to do a chi-squared test. All right, and watch this. We're going to do chi-square dot test, and we're going to set x equals to our frequencies. Now notice the frequencies are set up like a matrix, so boom, it works just fine. Paste, and bachinga, we end up with Pearson's chi-squared, a chi-squared of 10, 2 degrees of freedom, p-value of 0.00469, so we reject the null hypothesis that they're the same at the 95% confidence level. And if I go right up here, let's find out what they get. 10.722, 10.722. So we got the same answer. That's nice. Okay, easy peasy. That's our test for independence.